Since early times, man has been fascinated with discovering the origins of the cosmos. Similarly, man has often been influenced by his creationist ideas that some divine power created the universe and everything in it. They thought, if the heavens are divine and the gods created man, well then certainly the universe must be geocentric, meaning the earth is the center of the universe. Geocentric model: any theory of the structure of a solar system or the universe in which the earth is assumed to be the center of it all. Ancient societies were obsessed with the idea that God must have placed humans at the center of the cosmos, a way of referring to the universe. An astronomer named Eudoxus created the first model of a geocentric universe around 3080 BC. Eudoxus designed his model of the universe as a series of cosmic spheres containing the stars, the sun, and the moon, all built around the Earth as its center. Heliocentrism is the astronomical model in which the Earth and the planets revolve around the Sun at the center of the universe. Historically, heliocentrism was opposed to geocentrism, which placed the Earth at the center. These models are two explanations of the arrangement of the universe, including the solar system. A geocentric universe. Eudoxus' model placed a spherical Earth at the center of the universe. The Sun, planets, and the stars were then placed in a giant transparent spheres surrounding it. A model of the universe that has the Earth at the center is known as a geocentric model of the universe. Aristotle: An Infinite, Eternal, and Geocentric Universe. The ancient Greek philosopher Aristotle extended Eudoxus' model of the universe in the 4th century BCE. Aristotle's model of the universe was also geocentric, with the sun, moon, planets, and the stars all orbiting Earth inside the Eudoxus spheres. Aristotle believed the universe is finite in space, but exists eternally in time. Aristarchus and the distance to the sun and the moon. Aristarchus concluded that the sun is about 20 times further than the moon and must be about 20 times larger. This is because the moon and the sun appear to be the same size. This is the most evident during solar eclipses, when the moon blocks out the sun completely. Eratosthenes and the circumference of the Earth. Eratosthenes, who was the first person to measure the tilt of the Earth in about 240 BCE, Eratosthenes knew that the sun would appear directly overhead in the Egyptian city of Suinit at noon on the day of the summer solstice. This is the longest day of the year when the sun is at its highest point in the sky. Ptolemy and epicycles. Ptolemy developed Aristotle's geocentric theory of the universe in about 150 CE. Ptolemy knew that the planets don't appear to orbit in perfect circles around the Earth. Ptolemy suggested that a planet like Mars move in circles as they orbit the Earth, where the circles are called epicycles. A heliocentric universe. Copernicus and a heliocentric universe. The Polish astronomer Nicolaus Copernicus reintroduced the idea of a heliocentric universe On the Revolutions of Celestial Spheres. The Catholic Church would not have accepted the realist heliocentric model, and so Copernicus presented this idea as a mathematical model. Tycho and a Changing Universe. The Danish astronomer Tycho Brahe made some of the most accurate ever observations with the naked eye in the late 16th century. He disproved Aristotle's concept of a changing universe when he saw a new star in the constellation of Cassiopeia in 1572. Kepler's law of planetary motion. Tycho's student, German astronomer Johannes Kepler, first extended Aristotle's theory of spheres by arguing that they are separated by 5 polyhedrons. Polyhedrons are 3-dimensional objects with sides that are the same shape, like a cube or a pyramid made of equilateral triangles. Kepler also suggested that the planets might produce musical notes because they can be described with a frequency. Galileo and the telescope. Kepler's contemporary, Galileo Galilei, added further proof to the heliocentric theory in 1610, where he made several observations that contradicted Aristotle. Galileo showed that not everything in space is perfect and unchanging, and that not everything orbits the Earth or the Sun. Galileo created one of the first microscopes and was one of the first people to use the telescope as an astronomical instrument. Bradley and the Moving Earth. In 1725, the English astronomer James Bradley attempted to prove that the Earth moves using a phenomenon known as stellar parallax. Stellar parallax occurs because the stars appear to move as we view them from slightly different positions throughout the year. The size of the universe. The size of the known universe doubled in 1781 when the British astronomer William Herschel discovered the planet Uranus. The size of the universe increased by a factor of 8,000 in 1838, shortly after the German astronomer Friedrich Bessel first measured stellar parallax.
The expanding universe. Every model of the universe must include the expansion we observe. Another key element of the models is that the cosmological principle, which we discussed in the evolution and distribution of galaxies, is valid. On the large scale, the universe at any given time is the same everywhere, homogeneous and isotropic. As a result, the expansion rate must be the same everywhere during any epoch of cosmic time. If so, we don't need to think about the entire universe when we think about the expansion. We can just look at any sufficiently large portion of it. Some models for dark energy would allow the expansion rate to be different in different directions, and scientists are designing experiments to test this idea. However, until such evidence is found, we will assume that the cosmological principle applies throughout the entire universe. Since the expansion of the universe is the stretching of all space-time, all points in the universe are stretching together. Thus, the expansion began everywhere at once. Unfortunately, for tourist agencies of the future, there is no location you can visit where the stretching of space began or where we can say that the Big Bang happened. For describing the large-scale properties of the universe, a model that is isotropic and homogeneous, same everywhere, is a pretty good approximation of reality. The universe is expanding, which means that the universe undergoes a change in scale with time. Space stretches and distances grow larger by the same factor everywhere at a given time. Observations show that the mass density of the universe is less than critical density. In other words, there is not enough matter in the universe to stop the expansion. With the discovery of dark energy, which is accelerating a rate of expansion, the observational evidence is strong that the universe will expand forever. Observations tell us that the expansion started about 13.8 billion years ago.